The name of this experiment is Transistor Characteristics Apparatus with the Regulated Power Supply. This is the apparatus of transistor characteristics. So today we are going to construct common emitter amplifier. Okay. So we are going to do the connections of common emitter mode of the transistor. Okay. So in case of common emitter configuration, emitter is considered as a common between the input and the output. Emitter is a common. This is our emitter base and this is connector. This is for PNP transistor. This is our input voltage. This is our output voltage. And these are the voltmeters and milliammeters in order to measure input current, input voltage and output voltage. So now we'll construct the circuit of common emitter configuration. So this is our circuit and we're going to construct this circuit on this board. So as per the circuit, the negative of the input voltage is connected to negative of the microammeter. The negative of the input voltage को हम connect करेंगे negative of the microammeter पे. This is our microammeter जहाँ पे हम IB को measure करेंगे. IB is measured, okay? And उसके बाद में positive of the microammeter is connected towards the base, है ना? Positive of the microammeter से we'll take one wire toward the base, okay? And from the connector, we can clearly see from the connector, we have connected to positive of milliammeter, right? So from the collector, we are going to connect this to positive of milliammeter. The milliammeters is going to measure IC, okay, the output current. And then we can see that the negative of the IC is connected towards negative of VCC. So this is the negative of IC. And we are going to connect this to the negative of VCC. This is our VCC, that is the output voltage, okay? And then we can see the positive of VCC is connected towards the emitter and it's grounded, okay? So positive of the VCC, this is positive of the VCC and we are going to connect it to the emitter, we can see because it's common emitter configuration. Also, the positive of EBB, that is our input voltage, will also go towards emitter, okay? So this is the circuit connection. We have almost connected the circuit. Only one thing which is remaining is voltmeter. Voltmeter हमेशा parallel लगेंगे, ठीक है? Parallel towards the input voltage. So negative, positive of this voltage source will be connected to positive of the voltmeter. And from the negative, so this is negative है ना? तो negative से wire जा रहा है towards negative of the voltmeter, ठीक है? Similarly, we can say that positive of this voltage again connected to the positive of the voltmeter and negative is connected to negative of the voltmeter. ठीक है? So this is the circuit connection. ऐसे हमको common emitter का circuit connection करना है. Now we are going to determine input characteristics. Input characteristics में output voltage is always constant. Okay? In input characteristics, output voltage is constant. And we change the input voltage and measure the input current. So output voltage is kept constant at 1 volt. So the output voltage is kept constant at 1 volt. So let us set the output voltage at 1 volt, okay? So we have kept the output voltage at 1 volt because the output is at 1 volt. Now, slowly we can start increasing the input voltage and we need to know the input current, okay? So this is our input voltage and this is our input current. We are using this knob to increase the input voltage. We'll set the input voltage to 0.5 and let's note the current. It is 0, okay? And then we increase the voltage slowly and we note the current for the next reading. So for every reading, for every voltage we are noting down with a gap of 0.02, 0.5 to 0.6. And we can clearly see if the voltage is increasing, the current is also increasing, right? The current is also increasing as the voltage is increasing. So this is the input characteristics which we can see, the input characteristic curve. Okay. Initially our current was 0 and slowly as we increase the voltage we can see that the current was also increasing. So this is the input characteristic curve and the graph will look like this. We take the readings for different values of VCE. For different values of VCE, say VCE is equal to 1 volt, VCE is equal to 4 volt and VCE is equal to 7 amp. Okay. So for different values of VCE, we note down the voltages VBE and corresponding current IB. As the VCE for the second case will be 4. Let us keep VCE at 4 volts, and now again he'll repeat the same procedure, increasing the VBE and measuring the ID. Okay, the same procedure is repeated again, and the same procedure will be repeated for VCE is equal to 7 volts as well. So this is the input characteristics. In order to measure the output characteristics, we'll keep the input current IB constant. Okay, let us keep the input current IB to say like 50 microampere. Okay, so we have kept this IB to 50 microampere, and now slowly we have to increase the output voltage and measure the output current. Okay, we can see that when we increase output voltage, the output current is almost a constant. Okay, at 50 microampere, when IB is 50 microampere, on increasing VCE, we can see that IC is almost a constant. It is always on 10 milliampere, right? So the value of IC is 10 milliampere, IC will get saturated. The same thing is repeated for different values of IB. Say we can keep IB at 100 also. Okay, we can keep 100, 150, and we can repeat the same procedures. Keep on increasing VCE and know the value of IC. We can see that IC is constant. Okay, it does not change. Also, the graph which we obtain shows the characteristics wherein the input voltage VCE and the output current IC are plotted. We can clearly see here that the current is getting saturated. It is remaining constant. Okay, so this is the nature of output characteristic for common emitter configuration, and these are the calculations. From this, we can easily calculate the dynamic resistance and static resistance. Static resistance is VBE by IB. Dynamic resistance is delta VBE by delta IB. Similarly, we can calculate static and dynamic resistance in the output characteristics curve also. Delta VCE by delta IC is a dynamic resistance, and VCE by IC is a static resistance. So this is what we are supposed to write in the result: dynamic resistance and the static resistance. What is beta? Beta is our current gain, okay? The AC current gain is called beta. Beta is defined as delta IC by delta IB. It is the AC current gain. And the DC current gain is also calculated, beta DC, IC by IB, and beta AC is delta IC by delta IB. Both are calculated and written as the result. So this is the circuit, and this is the experiment. Transistor characteristics in common emitter mode, and we have calculated the input and output dynamic resistance, the current case. Transistor is a device. It has 3 terminals: emitter, base, and collector. Emitter is heavily doped and is of moderate size. Collector is slightly doped and is of large size. Base is lightly doped and it is of very small size. Okay, so they need to know the functions also. Thank you.